Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be studying Section 3 of Chapter 2, the standard form of a line. Currently we've already learned two forms of the line. The first form was the slope-intercept form, where we were given the slope and the intercept in the equation. The second form was the point-slope form, where we were given a point and a slope in the equation. So the standard form is going to require us to do a little bit more work than we had to do in previous problems, but it's all going to connect in some way, shape, or form. So the first thing that you need to know is, what does a standard form equation look like? So a standard form equation can take one of two forms. You could have something like ax plus by equals c, where x and y are on one side of the equals and a number is on the opposite side. Or you could have an equation where ax plus by plus c equals 0, where everything's on one side of the equation and nothing is on the other side of the equation. So we're going to take a look at both of these types of formulas and forms of standard form with our examples we're about to do. So our first example says, write 2x minus 3y equals 9 in slope-intercept form. So in order to do this, we have to remember that slope-intercept form is when y equals mx plus b. So when we have equations written in standard form, we have to convert them to slope-intercept form in order to create the graphs. So what we have to do is get y by itself. So the first thing I will do is remove anything that's not with the y. So in this case, that's 2x. Right now I have a positive 2x, so I need to do the opposite and subtract 2x from both sides of the equation. So on the left, I'll be left with negative 3y, and I need to write the right so it looks like mx plus b. So I'm actually going to write negative 2x first, and then plus 9 because it was a positive 9. Once I have the y part by itself, I then have to get rid of the number with y. So negative 3 is being multiplied with y, so I need to divide every piece by negative 3. So I'm going to have y equals, and then I've got to simplify the right. Two negatives would make this positive 2/3 x, plus a negative would make this minus 9 divided by 3, which is 3. So my slope-intercept form is y equals 2/3 x minus 3. And using this equation, we can create the graph like we've done in previous sections. So our next example, we want to graph the line 2x minus 3y equals 9. Well, in the previous example, we already said the slope-intercept form was y equals 2/3 x minus 3. So in order to graph this, we've got to pick out our slope and our y-intercept. So our slope is always the number in front of x, which in this case would be 2/3. And our y-intercept is what's added or subtracted. In this case, a negative 3. So when we graph this equation, we're going to plot a point at negative 3. And then we're going to count our slope, which is rise over run. So rise 2, run 3. And then one more time, rise 2, run 3. Once you have your 3 points, we're going to connect them to make our line. So this part is review. The new part is being able to put a standard form equation in slope-intercept form. So our next example, we want to write 8x plus 10y equals 40 in slope-intercept form. So slope-intercept form again is y equals mx plus b. So what we want to do, we want to get the y component by itself. So we have to do the opposite of the x value we see. So right now there's a positive 8x. That means I need to subtract 8x on both sides of the equation. So 10y. On the other side, x term first. and then plus 40 because it was a positive 40. Once I have that, I have to get rid of the 10 that's with the y, so I'm going to need to divide by 10 every piece to get y equals, and then simplify. Negative 8 over 10. I can divide both of those by 2. So that's going to give me negative 4 fifths x plus 40 divided by 10 is 4. So my slope-intercept form of the line, y equals negative 4 fifths x plus 4. So we want to graph 8x plus 10y equals 40. So using our slope-intercept form that we just found in the previous example, y equals negative 4 fifths x plus 4. We're going to pick out our slope and our y-intercept and create our graph of this line. So based on our slope-intercept equation, the slope's negative 4 fifths. The y-intercept's at the point 0, 4. So we're going to go to our graph. We're going to plot a point at 0, 4. And then we're going to count our slope, rise over run. We need to rise negative 4 and run positive 5. So down 4, run 5. And then down 4, run 5. Once you have your 3 points, we're going to connect them with a line. And then you have graphed your equation, 8x plus 10y equals 40. So again, this part's review. The new part is being able to write the equation in slope-intercept form. So our next problem, write 4x plus 5y minus 10 equals 0 in slope-intercept form. So this is an example where everything's on one side of the equation. So what we want to do first is get x and y by itself. So we're going to get rid of the number. So right now there's a negative 10. We need to add 10 to both sides of the equation. So we're going to have 4x plus 5y equals 10. And then it's very similar to the first two problems we did. We need to get rid of the x, so we'll subtract 4x on both sides because it was currently positive to be left with 5y equals negative 4x plus 10. And then I need to divide everything by 5. So y equals negative 4 fifths x plus 10 divided by 5 is 2. So our slope-intercept form of the equation is y equals negative 4 fifths x plus 2. So now we want to graph 4x plus 5y minus 10 equals 0. So we're going to use the slope-intercept form that we just found, y equals negative 4 fifths x plus 2, to identify that our slope is negative 4 fifths and that our y-intercept is the point 0, 2. So we're going to plot a point at 0, 2 and then count our slope, rise over run. We need to rise negative 4 and run positive 5 and plot our next point. And then just count it one more time. So that way you get 3 points here to connect into a line. So using the slope-intercept form, plot the y-intercept and count your slope. So our last example, we're going to write 2x minus 3y plus 3 equals 0 in slope-intercept form. So what we want the x and the y to be on the left-hand side to start. So I have to get rid of just the number. Right now I have a positive 3. So I need to subtract 3 on both sides of the equation to get 2x minus 3y equals negative 3. And then I want the y term by itself. So I have to get rid of the x term. Right now there's a positive 2x. So I need to subtract 2x on both sides to get negative 3y equal to negative 2x minus 3. Once I have the mx plus b part getting set up, the last thing is to divide by what is with y. So in this case, it's negative 3. So y equals negative 2 divided by negative 3 would be 2/3 x, because two negatives make a positive. And negative 3 divided by negative 3 would be plus 1. So our slope-intercept form for this problem, y equals 2/3 x plus 1. So the last thing we want to do is graph 2x minus 3y plus 3 equals 0. So we're going to use our slope-intercept form, y equals 2/3 x plus 1, to identify that our slope is 2/3 and our y-intercept is at the point 0, 1. So using this information, we're going to plot the y-intercept at 0, 1. And then count your slope. Rise 2, run 3. Rise 2, run 3. Once you have your 3 points, connect them with arrows on the end. This concludes our lesson on Section 3 of Chapter 2, Standard Form of a Line. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.